So I know we've actually already done a question kind of similar to this of just sketching a linear function, but I wanted to show you sort of like the power of just using these intercepts, the x and y intercept, to actually make a sketch of your function. The key word here is that we're doing a linear function. So this isn't going to work for every single type of function in your mathematical career, and you will get other ones. You will get things like quadratics later on in grade 11 and things, but for right now, since it's a linear function, there is a really cool way that we could do this. So we're going to start off by finding x and y intercepts. So let's find the x-intercept first. And if you remember from our other video and the notes, we know that the x-intercept is when our function value is equal to 0, or our y-coordinate is equal to 0. So we're going to set f at x to equal 0. 0 equals negative 2x plus 7. So our y-coordinate over here, or our function value, is equal to 0. So now we get to solve for x. So minus 7 from both sides, and we're going to see that this is going to be 7 over 2 equals x. So just kind of dividing by that negative and getting rid of that. So here we have our value is at approximately 3.5. Not approximately, exactly equal to 3.5. So our x-intercept, x-int, is at 3.5, comma, 0. Now, let's keep on going with this. Let's find out where our y-intercept is. And remember, y-intercept is when our independent value, our independent variable, is 0. So find, or rather, let me say, we will set x equals 0. So we're going to f at 0 equals negative 2 multiplied by 0 plus 7. Hey, that is equal to 7. So my y-int is at 0, 7. Finally, let's look at the rate of change. Now, in my question here, my rate of change is given to us. It's the number that is being multiplied by x. This is my rate of change. Later, we have a different word for this, and it's called slope, but it's negative, which means as we read from left to right, the graph goes downwards. So let's go ahead and let's put on our graph an xy plane. I'm going to use all 4 quadrants because we are dealing with a function that doesn't have a context. It's going to be a continuous function, continuous linear function. So I'm going to use all 4 quadrants, and I'm going to draw them all out because we don't really have any context and we don't know if it's all positive or negative, nor should we even assume that. I'm going to label out each one of these tick marks to be 1. So I'm going to keep on labeling out everything as I need to. I'm also going to label this as x, and this is y. And 1, 2, 3, 4, 5, 6, 7. It looks like I'm just going to have to kind of extend my graph just a little bit so I can get that in there. Oh, I don't think I can erase this, can I? Nope. So rather than that, I think I'm just going to have to draw over it a little bit, but we have 1, 2, 3, 4, 5, 6, 7. We're going up by 1 each time. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And I have a point at 3.5. So I'm going to put my point just in the middle between 3 and 4. And up here. And check it out. What we can do here is we can actually go ahead and connect these with a line. I would use a ruler for this one, but I have arrowheads on both of them to extend this, and I don't actually need to use a table for this graph. I can have both of these just as you see them here, just a y-intercept and an x-intercept, and then connect them up, following that this is a linear function. It's connected with a line. I could do this a lot of different ways in order to get to this final answer. However, I think this is going to be the easiest way to do it. Find our 2 points. It's a linear function, so they're connected with the line. And then you go ahead and connect them with the line. No table needed. And usually just kind of minimal work of just finding those 2 things. And that would be the end of this question.